first YouTube video. I'm super excited and honestly a bit nervous because this is my first time explaining a LeetCode problem on YouTube. So if you enjoy this explanation or find it helpful, do consider supporting the channel. It would mean a lot for me. So let's jump into today's problem. So this is 3983, the subsequence after one replacement problem. It was the last week's weekly contest problem. So first of all, you are given two strings S and T consisting of the lowercase English letters. You may choose at most one index in the S and replace the character at that index with any lowercase English letter. Return true if it is possible to make a subsequence. Yes, a subsequence of T. Otherwise, return false. So subsequence here means that it is a string that can be derived from another string but deleting some or no characters, without changing the order of the remaining characters. So we can call yes a substring of T if and only if the subsize of the yes is lesser than the size of the string T, lesser than or equal to, okay, and that the order of the elements are maintained. If the order of elements in the text T are C, H, A, and T, the same order should be maintained in the string yes. Then only we can call yes a substring of T. Okay, and if we can change one character of the yes to another and then it becomes a substring of T, then we should return true. Otherwise, we should be returning false. So let's get into the dry run. Okay, so I will just go to the full view. So let's take a string C, A, T and another string C, H, A, T. And the main thing over here is that the idea over here is that this problem can be solved by the prefix sum as well as the greedy approach. Over here, I will be doing the greedy or the brute force approach. It's both are looking similar actually. So in my approach, what we'll be doing is that the basic logic is that here I will be taking the first character of the first string. Yes, we'll call it yes, and we'll call this T. I will take the first character of the yes and the first character of T. We'll check if both are equal. If they were equal, I will move to the next character. Okay, next character in yes, next character in T. I will check both of them. If yes, the character in the yes, which is nothing but A, if it was equal to the character in T, which is nothing but H, we can move to proceed with the same thing. If they were not equal, I will use the token, okay, because I can change at most one character in the yes, okay, yes, to some character in T so that it will be forming a subsequence. What I assume is that I will take the first mismatched character, right? If they are not equal, I will consider this pair, right? I will consider this pair to be a mismatched pair and I will use my token, right? If I used equal to false, since first I will not be using the using the token, right? First it will be false and after I find a first mismatch, I will change this to true. I will change this to true after the first mismatch happens so that my token is over and I cannot change any character which is coming after this pair to match the to make it a substring of subsequence of T. Okay, that's the main idea. Now, if they are mismatched, what I will do is that take it, I use my token and I will proceed as if they both are equal. So what I will be doing, I'll be moving to the next character in yes and next character in H. So it will be T and A. I will check if both are equal. No, they're not equal. So I will check if my token is used or not used. As of now, the token is used. Okay. That one token which was given by the problem, I have used that token. So now I cannot change this character to another character. That cannot be done. So I can only check the further characters if they were equal to this character in order to check if that yes is a subsequence of T. So first I will be doing checking with this character. If not, I will be moving to the next character by iterating this pointer over here. I won't change this pointer since because it reached this end. Okay. And I will just move this pointer to iterate till the next end is reached. Now let me take two pointers I equal to 0 and j equal to 0. Okay, I is for the string yes and j is for the string t, right? I is over here, right, and j is over here. I will check if character in yes of I equal to yes of, I mean t of j. Okay, C equal to C. Yes, the condition satisfied. And then these both are equal. So I will move the iterator to the next of J. If it is true, if they are equal, I will do I plus plus J plus plus. Okay, so if they are, I will be moving to the next character A and H. I will check if S of I equal to S of J, and it will be like, it will be like A equal to H, and they are not equal. So what I will check is that have I used already my token? Okay, if used was false, I can take it as a mismatched pair. I can take this pair as a mismatch and I will make the use as true. Initially used was false, used was false, right? I'll make it as true. And after that, I will simply proceed with I plus plus and then J plus plus, right? So I will be moving here, I pointer will be here, and then J pointer will be here. I will check if both are equal. No, they are not equal. I know that. I will check if they are used or not. Already my token is used, so I cannot use it here again. So what I will do, I simply J plus plus. So J pointer moves to this and checks if they both are equal. T equal to T. Yes, they are equal. And hence, I will just conclude that I pointer is at the size of the string yes, right? Let's assume the size of the yes to be n and size of the t to be m. When I equal to n, after this step, I will be equal to I plus plus, right? I will be at the value of n. So finally, in the return condition, I will check if the I value equals to n, I mean the size of the string yes. Then the full string has been iterated. It means that the full string has been iterated and that all the characters in the yes follow the same pattern, I mean follow the same order of that of t. And so yes is a subsequence of t. Here there is one case that is to be noted, which is nothing but the letter yes may contain CAT and T may contain CHAT. What if the first character was found? For example, let's take this example where yes equals to WT and T equals to WX. The first character of the S will be checked with this. But here itself, I will check the mismatch happened and I will make the token to be true. I will move to the next element T and check if they are equal, not equal, not equal. So it will be finally returning the answer of false, right? But the actual truth is that it is true because only the first element is not matched, but it is already present in the next second element, right, of the third element of the text T. So that is why I need to store the element where the mismatch happened. It may also be present in the later coming letters, right? And that is why I have used this code trick where you can just see this. First of all, I have initialized n and m, which is nothing but the size of the text yes and size of the string t. And if n is greater than m, it's default. It's false. Okay, yes cannot be a substring of t. So and I've initialized the iterators I and j equals to 0. And I said, right, they use the token. I've denoted it by replacement used, and that is false initially. Okay, the token is not used. And to store the replaced character, I have used this character thing. So I am iterating using the while loop, like till I is lesser than n, size of the string yes, and j is lesser than the size of the string t. The loop will be iterating, and I check if I coming here, right? I check if the string character I equals to text t's character of j, right? S of I equals to S of j, and if they are equal, I will be doing I plus plus and j plus plus. Else, if they're not equal, what happens is that I will check if the replacement is used or not. If the replacement is not used only, I can use the replacement. I will be changing the replacement to be true and then storing the character S of I in the variable, and then doing the I plus plus j plus plus as usual. And if in case the replacement is used, I will be doing the j plus plus, simply iterating to the rest of the elements in text t, I mean string t. So this is the condition which I said. If the replacement is used, but the letter is found in the later place, right? Check if the replacement can be taken back. And in that case, I am using this condition. If the replacement is used and the replaced character, right, is not equal to the current character yes of I. So what I will be doing is that replace the character is equals to checking with the character in the text t, and if they are equal, and that j is lesser than the size of gam minus, I mean j is lesser than the text t size minus 1, I'll be doing the replacement is false, changing back it to the normal position, normal condition. And I will be returning if size of the I is equal to n, so that I can tell the entire string yes is iterated and finally returning yeah. So this is all about the problem. Time complexity will be O of n plus 1, n plus m, the size of the string yes and the text t. And then the space complexity would be O of 1. This is all about the time complexities of the problem. Thank you for watching.